Welcome everyone. In this video, I'm going to be going over intersections. This is the second lesson in probability. So we're going to be looking at a little bit more complicated of probabilities than we did yesterday. Mostly the probability of like two different events happening. That's called an intersection. So we're going to look at this first example. It says you roll a six-sided dice and then flip a coin. What is the probability that you roll an even number and flip heads? Okay, so there's two events here, and one of the best ways to think about probability is with a probability tree, okay? So in your first event, you could roll a 1. Actually, I need to make this a little bit smaller. You could roll a 1, a 2, a 3, a 4, a 5, or a 6, okay? And that's your sample space, right? But then you also have your second event, okay? So then you could roll out of each one of those heads or tails. A little bit crowded in here. Okay. And so this will let you kind of look at the sample space of the whole thing. And again, I know this one isn't that hard to figure out, but it's good to show examples of things with easy things. So we got 1 heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, and 6 heads, 6 tails. And all of those have equal probabilities of happening, okay? So it says, what is the probability that you roll an even number and flip heads? So if we look at all of these even number and heads, so we've got 1 right there, 2, 3, right? So three favorable outcomes, right? And then how many total outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability that we roll an even number and flip heads is 3 out of 12 or 1/4, okay? And that's one way, to kind of figure out these probabilities. So what we just found is called the intersection of, those two events. So the probability that events A and B both occur is called the intersection of A and B. And why is it called intersection? Well, you've got, two events. They're both happening. They're the probability that they cross, So the key word there is and, all right? So you're going to be seeing that word a lot today. The probability of the intersection of A and B is denoted by this, okay? So you got probability of A, right, and B. So this is called the intersection symbol. It's like an upside down U, okay? So you're going to want to remember what that means. And we actually have a formula here. It's called the rule of multiplication, all right? If events A and B are both independent, then the probability of A and B both happening is equal to the probability of A times the probability of B. So if you have two independent events, flipping a coin and rolling a dice are independent, then you can use this formula. So if we solve example 1 from above, right, the probability of rolling an even number we've already said is 3 out of 6 or a half. The probability of flipping a coin is also a half. So if we do a half times a half, we get a 4th. And that was our answer from above. So this is a nice formula. That way you can just multiply things together. You don't have to make the whole tree, but sometimes making the tree is helpful in certain situations. So we're going to look at a couple more examples. What is the probability that you roll an even number? All right, we've already said this. It's a half. What is the probability that you roll a number greater than 3? Okay, well, numbers greater than 3 are 4, 5, and 6, right? And there's 3 of those. We know it's out of 6 total outcome. So 3 out of 6, also a half. What is the probability that you roll a number that is even and greater than 3? Okay, so I don't want you to use the multiplication rule here. I want you to look at what we said above. How many numbers, right, are greater than 3 that are even? We've got 4 and 6, right? So our favorable outcomes are 4 and 6 out of 6 total outcomes. That's 2 out of 6, which is actually a third. But we already did the problem above where we had a half and a half and a half is a fourth. So we kind of have two different answers here. But I hope you can see that that answer is not right. I mean, this one, obviously, those are the two favorable outcomes. So why doesn't the rule of multiplication work for this problem? Those events are dependent. Dependent, okay? Looking at only numbers greater than 3 does actually change the probability that the number is even, right? There's 3 numbers that are greater than 3, 2 of them are even. That's not a half, that's 2/3, okay? So that changes the outcome. So that's why you can only do this if your events are independent, okay? So I know that's kind of hard, but sometimes you just got to look at the favorable outcomes like we just did here to see kind of what's going on. So that's the answer to that question. Last, just real quick vocab that's kind of thrown in here. Mutually exclusive events. 2 events are mutually exclusive if the probability of A and B is 0, okay? 2 things that cannot possibly happen at the same time. A lot of times it's a contradiction, but just a really easy example. What's the probability that I roll an even number and an odd number? 0. You can't roll an even and an odd at the same time, okay? So there's a lot of mutually exclusive events that you could come up with. So you've got a quick practice here, very short. Go ahead and give it a try. If you have any questions, you can always Canvas message me and let me know, and have a great day.